Okay, thank you. Good morning. Still morning, yes. Now I know why they move them further and closer. Okay, my name is Taun Chapman, and everybody always asks, Taun, like, where's that come from? What is that? So one parent wanted Sean, the other wanted a T because of monograms. Everybody knows about monograms, right? You know, those letters that go on suitcases and stuff like that. Somehow my dad was in the monograms. So my name is Taun Sean with a T, thanks to monograms. A little bit about me before I get into the talk. I was preparing for this and trying to figure out what in the world am I going to talk about. And I realized, that project I worked on about 30 years ago for a nuclear magnetic resonance machine, that was home enabled. Like it went from, it was real time operating system, which then had a network connection to a VAX, which then had people able to dial in remotely because the research scientists need to be able to check on the status of their experiments. And I'm like, you know, that's IoT. So this, of course, is an IoT talk. And I just, wow, IoT for 30 years. So I'm from Fellows. I'm a staff engineer with Fellows Brands. Anybody here heard of Fellows? Fellows, well, yes. Okay, a lot of people. Anybody? So what do you know about Fellows? Anyone? Your AC thing? Maybe a different Fellows. Anybody else? You know about Fellows? Someone else raise their hand. Stapler. Well, the funny thing is, we didn't actually make staplers, but everybody thought we made staplers. So now we make a stapler. Only because everybody thought we did. So Fellows was founded in 1917. It's a privately owned business founded by Harry Fellows. They created bankers boxes. Has anyone heard of bankers boxes? Yep. Okay. Again, a cardboard box for banks to put their documents in that they need to archive, right? They take them out of the regular file system. They want to put them into some warehouse and save them for the 10 years or however long you need to save documents. So Harry Fellows came up with a banker's box made out of cardboard, 1917. We still make those. It's still a product. Time goes by. Somebody came up with the idea that we need to diversify. It's not enough to make bankers boxes. What else are we going to make? Now, I must mention this is not the official history of Fellows. This is my version of Fellows. So I am riffing a little bit here, right? I'm thinking, okay, we supply bankers boxes. People put paper into these boxes. We want to diversify. What do we do? Well, what happens to the paper after the box? It needs to get shredded. We'll make shredders. So Fellows diversified into shredders. Then, of course, the question is, what happens before the paper goes into the box? Well, it needs to be collated. It needs to be stapled. It needs to be laminated. We'll do all that stuff too. So we're basically getting involved in the life cycle of paper, which is office products. At some point, we ask ourselves, okay, we need to diversify some more. Office air quality. Don't ask me how that one went, right? Like office products to air quality. But so we started doing air purifiers. I don't have the date up there, but the first air purifier that we did for commercial use that we designed and built was 2014. So 2014, we're doing air purifiers. We're doing office products, bankers boxes still. Then COVID. Everybody knows that one, right? COVID hits. We're all in lockdown. The whole world's going crazy. We're a small 103-year-old privately owned company. We sell cardboard boxes, paper shredders, air purifiers. Scientists, everybody's trying to figure out, is it airborne? Is it not airborne? Where's it? How are people getting it? What's happening? we happen to sell an air purifier. And almost overnight, sales for air purifiers skyrocket. And we have a supply chain. We have an excellent supply chain, global. So how do we take advantage of this opportunity? What do we do? So again, 103-year-old privately owned company, but with zero software experience. I'm not counting firmware as software. So we're small, we're privately owned. I worked for Bowery. They just went bankrupt. They had $600 million in funding. Fellows does not have $100 million. No one's giving us $600 million. So we have to be efficient. We have to make it work based on just the money that's coming in. We do mechanical design. We're good at it. We've gotten awards for mechanical design. This is some of the products. There's the shredder. Electrical as well, right? The air purifier has microcontrollers in it, has system for controlling the fans, sensors. It's aware of its environment, so it can change fan speed based on the environment. That's all firmware. It's embedded. We're good at that. But again, sales skyrocket of air purifiers. What are you going to do? Well, don't mess around. Go big. We came up with a product called Array Plus Viewpoint. It's all of that. 9 products. So we had our existing, the outline didn't work very well, but there's a green dot around 2 of those over there. If you look for it, green dotted outline. So we had a line of existing air purifiers, standalone. They would go on a wall, or they could just sit on a little metal stand. You can barely tell, but there's a little metal U-shaped bracket that it sits on. So they can just be put in whatever room you want to put them in. Those we had already. And again, they had that microcontroller. So they're standalone, everything works great, but we want to IoT enable it. So we want to IoT enable our existing products, already have a microcontroller built into them. But we also need new products. We want to be able to do the whole office space. And what does most offices have? Drop ceilings. People don't want air purifiers sitting in the middle of their conference room, right? They want it blended in nicely. So we need to do a drop ceiling unit. Some open spaces don't have drop ceilings. Like right here, we look at the lights here, how all the lights are suspended. Well, we need an air purifier that blends in with this, that we can suspend just like the lights here. And that's what you see again with the last green lines. It's hanging there right beside the text. I wish I could like put the mouse over there, but I can't. That's what we call the JAWS. Is it JAWS, Christian? Yeah. The project name was JAWS because everybody knows Jaws from James Bond with the teeth. So that had a chrome outline, which was just like the chrome teeth of Jaws from James Bond, a villain. We're also adding a way of monitoring. That's what this is right here. It's a display. It can go on the front desk when you go into the office. It can go on a wall somewhere, and it would give the current status of the air quality. I don't know what it's displaying right now. Let's see. Cleaning. Okay, it's working. Woohoo, I just set this up 5 minutes ago. Onboarded it and everything, along with what's over here. So we're going to do the monitor. That is this guy right here. This is for sensing the different environmental attributes, CO2, parts, particulate matter, VOCs. We're going to have a dashboard. And I'm not going to show it right now because I don't want to lose my slides. But later on, I'll give a demo of the dashboard. Touch-sensitive tablet. We're going to do all of this, right? Zero software experience, no IoT, We know air purifiers, mechanical design, firmware. These units are going to have physical interfaces. They're going to have buttons. You're going to be able to manually change fan speeds, change modes. So whatever you do, you have to be able to handle button interfaces locally. We're going to have to interface with sensors, microchips, right? So there's going to be a CO2 sensor, VOC sensor, particulate matter sensors. Who knows? There's going to be filters, consumables. Everybody loves consumables, right? Connectivity. You have to be able to handle Wi-Fi, LTE, BLE, Ethernet. It's going to be receiving commands remotely over the internet, right? So somehow on the system, you have to have command processing. It's IoT, and it's all the IoT things. We have to implement a dashboard, which can send commands from the dashboard to a particular device. Has to be responsive. You have to be able to get feedback, right? Has to be synced in terms of state. It's no good if the state's not the same on your dashboard and on your device. And we want to do modern development practices. So you have a problem, you have a new product you want to roll out, 9 different devices, all IoT enabled. How are we going to solve it? And that's not all. Sensor sharing, still outlining the problem. This is pretty unique to our product. Let's say you have 10 air purifiers in the office spread throughout the office space. They all have local sensors on them. Just like this right now is censoring the air quality and it's saying it's not great. This would be blue if it was perfect air quality. So right now, I haven't looked at the dashboard yet, but our air quality is not 100%. So with sensor sharing, right now this is turned not blue. And imagine we had a bunch of air purifiers hanging from the ceilings. It would send its data to the cloud, and the back end would tell all the other air purifiers, hey, you may not be sensing it, but there's poor air quality and it's probably coming your way. So why don't you ramp up your speed right now and get ahead of the game? So sensor sharing, we're sending the information from one area and propagating it to all the other air purifiers in the space in real time. We need a system that can manage that. But you also have to have custom control, something about business logic, right? Like that one over there is in a conference room and they said they want to stay quiet. So even then, though you said sensor sharing over here, there has to be enough smarts over there to say, no, you know what? We're having a meeting. We're going to stay quiet. We're not going to ramp up our speed. So that's cloud mode, quiet mode. We have to do motor control, managing the sensors, getting the CO2 values, starting sensors up, shutting sensors down, calibrating them, all the things you would do for a sensor. That all has to be managed locally on the device, but also be able to manage it from the cloud. And of course, there's going to be obstacles. We are a global company. So this is not your backroom project, right? Whatever we do, 20 different languages. Now for IoT, that might not be a big deal, but when you're talking about the viewpoint dashboard for it, 20 different languages. We really like icons. You don't have to translate an icon. Worldwide connectivity. Okay, so you want to go with cellular, but what about cellular in China? What about cellular in India? Suddenly you're talking about a lot more hurdles besides just getting something with Twilio working in North America. We don't have a customer service infrastructure, right? We weren't a company, we sell you an air purifier, it goes off, that's the end of it. But when it's IoT enabled and people are paying for a subscription, they're paying for the product, it has to be reliable. We don't have people all over the world that are going out to support and repair this. It has to not be repaired in the first place. or always be connected. Compliance. Again, if you're doing this at home, whatever you do, it's easy, right? You just plug it in, it works, no problem. When you're trying to ship it as a product, okay, so you need to do FCC approval and UL approval for the US, North America, before you can ship it anywhere. Now you want to go to Europe. That's a whole nother layer of compliance. You want to go to Asia, another level of compliance. Suddenly everything balloons and skyrockets in terms of time to market, difficulties, complications. No one knows this more than Christian over here, who's also from Fellows. He's with the compliance team. And we had no pre-existing platform. It's not like we're just leveraging what we had and it's scaling it, expanding it, adding features. No, we're starting from zero. So what do you pick? How do you do this? What are you going to use that'll let you achieve these goals without failing, just from the weight of it, right? The complexity of it, the number of products. Any idea? Yeah, it's a trick question. Why else are we here, right? So, of all the things out there, I'm really amazed, but I wasn't with Fellows at the time. How do you make this choice? Right? We all know that Elixir is not the most popular thing in the world. It's a tough sell to say use Elixir, even tougher sell to say use Nerves. And I would say in part because Fellows is a small privately owned company that they were able to take this risk and say, yeah, we're going to go with Elixir and Nerves. But what do you get when you decide Elixir and Nerves? What's happening? Like, what's the benefits here? Well, it's not just that you're using Elixir and Nerves. Yeah, Elixir is awesome. We all know that, right? That's why we're here. OTP, it's robust. Front end, back end, it does embedded, cross-functional. You have Nerves, Elixir on Linux, so you get all the benefits of Elixir, but it's on Linux and then embedded. Awesome, right? With Nerves, you get circuits. Now you can interface with sensors. And nice, easy sensor libraries. That's awesome. I2C, UART, doesn't matter. And you don't really need drivers. The sensor's I2C, as long as you have the specs for it, you just send I2C messages. You don't need to have a pre-existing driver. You just need to have I2C and circuits. VintageNet, you get Wi-Fi, you get LTE, you get QMI, you get a regular old Ethernet. So VintageNet, that's an awesome library, really well written. Nerves Hub, open source. Managing your fleet, over their updates. Someone mentioned console. Awesome, right? You get all of that. Maybe some code sharing. You definitely get knowledge sharing if you're using Elixir in your back end and you're using it on your embedded. But there are risks. Not many Elixir experts. Knowing Elixir is not enough. We talk about Elixir and how great it is, but really you have to know the whole ecosystem, right? Just learning the syntax of Elixir is nothing. Learning all the libraries, learning about supervisors, learning the OTP. I just learned last week how much I didn't know about supervisors and gen servers, especially on Terminate. Another guy and I were looking at it and going, this isn't working the way we thought it would. And we go through the docs and we start playing with it, put together a playground and go, oh my God, all these years and we did not understand this about gen servers. Another talk someday. Same with Nerves, not a lot of experts. Now on top of knowing everything about Elixir, knowing OTP, knowing gen servers, knowing supervisors, you need to know about hardware, all right? You need to know a little bit about Linux, but you also need to know, how do you use a UART? How do you use I2C? What's the protocols for I2C? What are the things that can go wrong with UARTs? You have timing issues all the time now. And we all know there's not a lot of examples. Last night's dinner, there was a lot of talk about how all the companies aren't really going public. We're here. Fellows is going public. But with those other companies that are sort of hiding out and saving their secret sauce, you can't follow them, right? You don't know that it's happening because they're not publicizing it. And so you don't have examples for all the success that you could have with it. They're trying to keep it secret. But if you keep it secret, you can't grow adoption. If you don't grow adoption, you can't have more people that know it. And if you don't have more people that know it, who you going to hire? So that's why I'm here. I think it's in our interest to be public in order to spread the word and be able to grow Elixir and Nerves so that there's more people to hire and less risk in terms of adopting these projects. Last risk, especially for fellows starting 5 years ago, you don't know what you don't know. And that's always huge, right? Anyone who's ever started a new project and you think, oh, there's 5 steps. 25 steps later, you're halfway through. Nerves isn't the only game in town, right? I mean, people have been doing IoT since before there was Nerves. They must have been doing it somehow. Could have chosen something else. Could have gone with Zephyr, RTOS, low power. They have OTA, right? There's different third-party OTAs. That's what everybody else is doing. But we felt that Nerves would be faster iteration. You have the OTP, you have the higher level abstractions. There's more room to expand in the future in terms of adding features, adding functionality. So Nerves it is. Slight change in pace now. I'm just going to quickly go over what we actually ended up doing. This is our hardware for our Nerves platform. It's pretty plain. Remember, we're doing all this during COVID, so a lot of these choices were based on supply chain limits. It is not, this is the best thing to use in terms of hardware or not the best. This is what was available at the time. So we're using an IMX6. That's roughly the layout of the board. You have Wi-Fi, you have LTE, UART, I2C. I have that little box there at the bottom, pre-existing AP, to show that even though we were using Nerves and we had the IoT board, we're still trying to interface with a pre-existing microcontroller on the pre-existing air purifiers. And that same microcontroller got used for our new air purifiers. So we have a bit of a hybrid system here. You have a lot of business intelligence in embedded C firmware, but you're also talking to Nerves. And that's important for when we get towards the end. LTE, our primary form of communication was LTE. A lot of people might say, why not Wi-Fi? Why not Ethernet? Even better, right? It's more reliable. Well, compliance. Remember, this has to be certified, FCC certified. And for every radio that you have, that has to be certified. And if it takes like 6 months to certify for LTE, and then it's going to take another 3 months if you add Wi-Fi and you want to ship it yesterday, well, then you end up leaving Wi-Fi out. So right now we're 100% LTE. Software is pretty much a standard stack. It's pretty normal. There's not much variety there, right? We have in the cloud, we have Timescale, Viewpoint dashboard, gets all its data from Timescale, AWS IoT Core, Peridio, which is basically Nerves Hub that went private. We have our CAT M1 for our connection, Nerves, and then we have our MCUs where we're sending speed, getting sensor data, CO2 information, all the rest of that. Customer control, right? It's coming from Viewpoint through the cloud, AWS. So we use MQTT for all of our communications. I thought people might like to see the actual architecture. So I've just sort of thrown this on. This is Mermaid. It's not the greatest way of presenting it, but I couldn't think of a better way as of last night at midnight. So here I'm going to zoom in. there's a lot of, for me, controversy here. I really like this architecture, but I also find it sort of controversial. I almost wish I had a laser pointer here. Oh, someone has a laser pointer. Multiple laser pointers. Yeah. There we go. Okay. So I don't know how many people have done apps outside of their app, right? Like you have app A and you've made your Elixir project and it's called app A and it has some dependencies, and then you have some things that start up in advance. We sort of did what might be called a poncho. It's like an umbrella, but it's not really an umbrella, but it's not really a poncho. So this Bionic Eye, this is like a library, but it's when we start up explicitly before we start our app up. So Bionic Eye is running before anything else is running. It's a dependency, but it's an app as well. You think of it like a library, but a library that we've started up first. And the whole point of that is when you're starting up your app and you have your children, right? So your app has 5 children, you start up, you go through all the children. If any one of those children crash, your app crashes. And how do you know how your app is doing? One of your children crashed, your app's crashed, but your app is doing all the talking, it's doing all the communication, and it's gone. So we pulled Bionic Eye out, and it starts up. It's very simple, no gen servers. There's no way really for it to crash. It does start up a few property tables. For anyone who's not using property tables, I love them. They're awesome. There's property table. They're subscribable. So it starts up some property tables. One of the things about property table is, of course, it uses start link. So whatever process starts the property table, if that process crashes, the property table disappears. Of course, it gets rebuilt, but everything that was in it disappears with it. So having the property table be part of our regular app where it might crash, we're going to keep losing data. By having it be part of our Bionic Eye app, that's not going to crash. There's no gen servers. It's just sitting there and it just has these property tables. So now our main app can access the property tables, and no matter how much it crashes, they stay up. Other parts of the app can also subscribe to property tables when fields change. So that's really convenient. It's PubSub, but within Nerves, without Phoenix. This LED status indicator, that's this light right here. Same kind of thing. We want to be able to, when it starts up, know what the status of the system is. Did our main app actually start? Is the system connected? Is it working? And if it isn't, why not? So again, we have this standalone app that started in advance of the main app, whose sole job is to communicate via I2C with this light and prompt the rest of the system for its health. So it's basically like a health indicator. Did our app start? Did our app start up? Yes? Okay. Do we have connectivity? Yes? Okay. And it just goes through the steps. And no matter what happens, no matter what crashes, again, this doesn't crash. This is as simple as it can be. We don't change it. All it does is send out the status. So it's pretty stable as well. So we can always have an indication of how is the system, especially when it's being installed, right? When there's bad internet connection or LTE is not working, you can immediately see that, hey, your LTE is not working because of the way it's indicating the lights. On that chain, we also have our Nerves hub connection, Peridio, and this is our modem driver. So like everything else, our modem driver is a standalone app. It just connects, it does its thing. It's a whole nother talk around that driver. But it just sits there and just works, and the rest of the app depends on having this modem connection at some point. Our application, our internal code name is Blofeld. I have nothing to do with that name. I am not a supporter of the villains, but that's what the name is. Hence the Drax and Jaws code names for the actual air purifiers, right? It's all Bond. So the app is Blofeld. We're now finally starting the application. Everything else was pre-app. We're now into the actual application, which is using MQTT, Tortoise. I think anybody who's done MQTT has probably used Tortoise. We have a gateway. We have our driver. We have a bunch of supervisors. So this is all pretty standard stuff. One thing I really like here is our gateway, our MCU gateway. It's switchable between UART and I2C. So we have air purifiers. They're UART. We communicate with that MCU. But we also have this device, which is all native I2C. So we can use the same firmware for both. We use the same drivers. All of this is the same. These sensor drivers, they're going to be thinking they're talking to I2C, and it doesn't matter whether they are or not because they're going through this gateway. And maybe the gateway is doing UART communication. Maybe it's doing I2C communication. Sensors don't care. It's the same payload. The drivers just work. So that's pretty awesome. Each one of these is a separate gen server, and which is also really nice with a separate supervisor. So if any one of those crash, they all have their own timing. They all have their own cadence. They're doing their own polling of the sensor data. We collect data every 15 seconds. And each one of those sensors just has their own 15-second send after, right? It gets the message, talks to the I2C chip, gets its data back, reports it to the property table. So all of our data just gets aggregated in the property table. And then there's this IoT gateway up here. And it is our interface to the world, the IoT gateway, right? So all it has to do is look at the property table. And maybe it has a cadence of reporting to the world every 5 minutes, whatever that cadence is. Every 5 minutes, it'll just go to the property table and say, hey, what's the sensor data for now? And then send it up to the cloud. We don't have to worry about a lot of synchronous communication. We don't have to worry about a breakdown and sort of lines of communication, right? Where A calls B, calls C. Nope, it's just a nice standalone little gen server talking to a sensor and sticking the data into a property table. Doesn't matter how many times it crashes. Any questions about all that? Anyone saying, yeah, that sucks? That was a terrible architecture.
You were talking earlier about property table is great. It's pub sub without Phoenix, right? So our gateway over here, the gateway I see is seemingly unconnected to these children way at the bottom.
Right.
And perhaps I missed a key word here, but we have pub sub here, right? So these individual children are doing their thing, but the gateway should be able to immediately know, right? And so if we've got our, individual cadences,
Right.
we should be real time with the gateway at the exact moment that those get updated. Did I miss that part, or is that how it works?
We don't care about that part
Okay.
because the sensors are every 15 seconds. And for the most part, we're publishing every 5 minutes.
Okay.
So whether, a sensor reading had happened 1 second before the 5-minute publication or was happening 14 seconds after the publication, we have a set of readings on that 5 minutes.
Okay.
The jitter between the readings doesn't really matter. Our CO2 is not changing that much in 15 seconds.
Tends to work that way.
Temperature and pressure is definitely not changing that much in 15 seconds.
Got it. All right. Thank you.
But remember, it is pub sub. The IoT could subscribe to those values if it wanted to. But then you'd be getting 10 different messages, and which one do you send on? Any other questions related to the architecture? Like having separate apps? Okay. Time for a demo. See if I can do this. Where? Ah, there it is. Found it. Hopefully everybody can see this. So this is the viewpoint dashboard. This is one of the devices. I don't know if it's this one or not. I didn't actually get the chance to check that. But I could check by pinging. It probably will not ping because I'm not sure I got the right one. But this is the user dashboard. So this is what people who buy the system would be using. Mostly it'd just be the people running the building, right? Not the individual office dwellers, the employees. So you can see it's good air quality right now. And you have your list of devices. It's fun trying to navigate this way. I can't see it. I should have done mirroring. Um, Areas, buildings. This is Philadelphia. This is me. I didn't mention that we're in Chicago. Fellows is based in Itasca, which is a suburb outside of Chicago. So this is our Itasca building. This is where Christian works out of. We also have Fellows Office Products in China, which is a fellow subsidiary run it in China that manages a lot of our manufacturing as well as our firmware development and electrical engineering. So we have a Chinese office. We have Chicago. I'm in Philadelphia. Don't pay attention to that one right there. You'll hear about them later. So here's our history of our air quality coming from Timescale. How many people have used Timescale? A few. What do people use other than Timescale if they want a time series database? Anybody? A file, CSV file. Yeah. So that's our dashboard that users use. We, of course, have a Grafana dashboard. This is the status of my development devices right now. It's really awesome. We can figure out what firmware version everything's on, whether it deployed successfully, how many units are online, offline, what the current status is. This is all of our sensor values. So just for the development devices in my office, this is the CO2 with respect to time. And of course, with Grafana, you can go back in time, move windows, do filtering. Grafana is awesome. Anyone doesn't use it, I love it. Yes. Yep. Yeah, we have Timescale as a data source for Grafana, along, of course, with AWS and CloudWatch and a lot of other services are all configured as data sources. Nerves Hub, right? I mentioned Nerves Hub. That's one of the magical features of Nerves is our console access. I don't know if you can do. Anyone know if you can do that with Zephyr console access? Yeah, that's. So we have console access to our devices right here. It is a live device. It's online. I could shell in there right now. I'm not going to. Um, and of course, there's the fleet. These are all the devices that are in my office. They're all online right now, different versions, everything. I can access them directly. And that is, there's one more. Come on. Ah, lost track of my mouse. This 71% corresponds to this light right here. So I think that might be the sensor that this one is. I didn't quite have enough time to figure that out, but yeah, see, it's only just come back online here. So I'm pretty sure that's this device. So this is the history of it. And the issue right now is we are dealing with pretty high CO2. So how many people have home offices? Okay. And you go into the office, maybe you have kids, maybe you have pets, maybe you have a wife who also has home office and she's talking loudly in in the other room, right? The bedroom or wherever room you have. And you close the door. You start to feel tired after an hour or two. Yeah. Maybe you need a CO2 sensor. How many people actually measure the CO2 in their home office? Awesome. That is excellent. And how high does it get? Yeah. Yeah. Oh, yeah. I think for I always suffered from that. And I finally got my CO2 sensor, and it's about 2 hours. If I sit in there with the door and window closed, 2 hours, I'm starting to feel, what's wrong with me? I didn't have enough coffee. I need more coffee. Actually, no, just open the window and maybe the door. One of the places I worked at, we had a conference room where 20 people would be in there, right? And I'd be great all day. Like, yeah, this is a great day. Wow, let's go to this meeting. Get into the meeting. Oh, my God, what's wrong with me? I don't understand. I can't move. After 5 minutes, just 5 minutes with 20 people in the office, was the conference room was very small, like 20 people just fit. So I really wish they had something that showed me what the CO2 was. I really wish other people, other companies had this. And now we could then go into the conference room and go, hey, everybody, we need to open a window or something, or maybe we need to get out of here because there's just no oxygen left in this room. You'd have actual feedback. Feedback is important. Feedback is vital. I'm trying to get back to my presentation now. Any questions about the dashboard or Peridio, how we manage our fleet?
Back to the architecture diagrams that you were showing, you had the Gateway app that's looking over the various sensor drivers. How much variability do you have with the sensors? I'm imagining you're not trying to track 20 different CO2 sensors, or maybe you are. Maybe for every batch of air purifiers, you're getting a new sensor from a new supplier, new supply chain. What's the variability of that? And then how are you abstracting that at that level?
The variability right now is very low. Like, for example, we have the same CO2 sensor across all of our devices. Some devices, we might have a different pressure sensor or different VOC sensor, but our CO2 is across the board. Christian is just learning nerves. He's just learning Elixir. And one of his very first tasks is, how do we abstract? I've basically come up with the API for a module I call command, and it is for composing the commands to a sensor and then parsing the response. So it's one module that's responsible for, you tell them, like, there's one for CO2, right? So there's a CO2 command module, which implements this behavior. And you might say, gather data. That's one of the APIs, gather data. So you send the command to the CO2 module and say, hey, put together this payload for gather data. It puts the bytes together, knows what the address is, calls the I2C gateway, gets sent, comes back, it gets a response, parses the response. And that's all handled just by the CO2 module. Other modules have the same thing. They each have their own command. They all do the same behavior. They all do gather data, and they just know how to put bytes together and take them apart again. Did that answer the question?
And this will get a little in the weeds, but you obviously
Weeds are good.
You obviously know what the hardware is. Are you refactoring that back into the software that's running on all of your devices, or is it not necessary to do that because you know the CO2 driver is not going to change in this air purifier that's already out in the field? Are you building a library of all the different hardware so that the software doesn't, it already knows what that sensor chip is, knows its properties, knows how it wants to talk, and you're just calling from that library? Or
We're
do you
putting
not care
together
about refactoring?
command drivers per sensor, right, for a particular sensor type. The array, you see array driver up there, its job is very simple. It's to know which sensors are for a particular model. So it's the array that looks up, oh, I'm on what we call an AR1. And AR1's CO2 sensor is this type. So I'm going to instantiate my sensor using this driver. And that's all handled at the array level. And we do have different sensors, so different arrays. We have 6 different models. 7, actually.
Got it.
Why do you use the same sensor? Are you trying to make sure that you've got qualifications for the general specs for so you don't have to actually recalibrate them yourselves, or what?
You mentioned the C word.
Yeah.
We're not going down that path. Calibration, that's a whole conference. But in terms of the question, why using the same sensor? Just ease of life, right? We know what the properties are for the sensor. We have to worry about supply chain. We have to worry about inventory, manufacturing in China. You're going to buy 1,000 chips. They're all going to be the same chip, right? We're going to put them together on a board. So these are all on a sensor board. They're not plug and play. They're not I²C where you just plug them in with a wire.
So it's not because of calibration. It's just because of ease of plug compatibility to your board.
It's the chip that was selected by our supply chain. And
okay, that's okay.
Yeah.
Okay, that's an okay answer.
But there'll be a change in the future. That's coming up. Future slide. Any other questions? Okay. Did the demo. So it's been about 5 years. We have all of these products in the field. They are all being sold. Customers are buying them. They're all in use right now. So, yes, the project did not come in on time. COVID, it's software. It's hard. But 5 years in, with the company that had 0 software experience, who picked Elixir and Nerves, is shipping all these products. And I can say right now, they are stable, right? We did have, and hope I'm not going to jinx myself, but we did have, I think, 1 outage in the past year, and that was our carrier. They were updating their relay code, and they made a mistake. But the software has been excellent. Nerves has been awesome. It's worked for us. I'm getting ahead of myself. There were lots of teething problems. It did take a lot of work, but remember, we're starting from 0. So you don't know what you don't know. What were the issues? Well, uptime, connectivity, get into that later. It was V0 architecture. All of that would be another talk. That's the voice. We started talking about the onion. I didn't actually start talking about it. Abelino and some other people would mention the onion. Our fellows management, why is it taking so long? Well, we just peeled back another layer of the onion and found another layer. A month later, why is it taking so long? Yeah, we peeled back 2 more layers and found another layer. We haven't gotten to the center of that onion yet, but I think actually we have gotten to the center of the onion. There is no more onion. 5 years in, the onion is gone. It has been totally consumed. Not going to go into that. It is very reliable now. It is Elixir, right? Nerves, Linux. Reliability has not been an issue, whether it's backend or the IoT devices themselves. So my conclusion is gone amazingly well for a company that started from 0, 5 years in, with 9 different products, a back end, a front end, touch panel, wall-mounted devices, just all of it. It's sort of mind-blowing. Specifically, what went well? Of course, Elixir, Nerves, Circuits, VintageNet. Circuits has been awesome to work with. I've always liked working with Circuits. I like the design of it, the way it works. VintageNet, I had to really dig into VintageNet over the past year and look at the architecture and how it's implemented. I like VintageNet. You have console access. Shout out for people. There's been talk about how do you do telemetry from IoT? How do you get it to the cloud? And usually the response is, well, you shell in and just look at it locally. One of the things I love for looking at it locally is Mobius. Anyone heard of Mobius? It's pretty much a dead SmartRent project, I think. Exactly. It's a dead SmartRent project. But so Mobius is telemetry, local telemetry, right? I showed Grafana, and Grafana is, it'll give you metrics like how many restarts did you have in a day? And Grafana, you can get that. Well, Mobius will do the same thing. So when I talked about it's been reliable or not reliable, what I like is I can go into a device, check Mobius, and find out, oh, VintageNet restarted 10 times today. And it's hard to get those metrics otherwise, but Mobius, standard telemetry. This telemetry that you would use on an Elixir backend and send that to Prometheus. We just do the same telemetry, but send it to Mobius. It's stored locally, and then I can find out what's our average RSSI for today. What was the worst case RSSI? What was the best case RSSI? And that's all just standard telemetry. Ring Logger Viewer. Anyone used Ring Logger Viewer? I love Ring Logger Viewer. And we have actually contributed some PRs to Ring Logger Viewer. So of the non-frank percentage, we are 0.0001% of the non-frank percent. Ring Logger Viewer, for those who haven't used it, it's the GUI of Ring Logger, right? So regular Ring Logger, you might go next, 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 and you get a stream of logs going past. And yeah, it has grep capability that I've never used. It has filtering capability that I've never used for regular Ring Logger. Ring Logger Viewer exposes all that in the same way that a GUI exposes it. Suddenly now all you have to do is go G, and it'll give you a text output, right? It'll give you a table. So ASCII table of your data, all your log entries, and G for grep, and say, give me anything that matches frame. And boom, those are all your logs for frame. Then you can concatenate stuff like say, okay, give me anything for frame, but I only want level warning. Oh, and I only want stuff that matches application VintageNet. And it'll just aggregate all that in terms of a query. And now you're querying your logs. VintageNet, warnings that have frame in the message. That's really great for spelunking into what happened. It also has persistence, tunable persistence. You can set up different buffers for your Ring Logger. So a separate buffer for your errors versus your warnings. So your error buffer might last a whole month because you only get 50 errors. Meanwhile, your debug buffer can just roll around over and over and over again every 2 minutes, and you don't care. So I highly recommend Ring Logger Viewer. OTA, I'm not going to go into that. We have contributed PRs to Nerves. I'm really happy about that. We've been able to do that. We're going to be contributing more as much as we can. So I mentioned 9 products. 8 of those products were designed from day one, like they were a goal. They need to happen. One of those products was only conceived of in the past year and then delivered within the past year. And it's called BACnet Relay, Building Automation and Control, which is basically a standard, industry standard, sort of like cargo containers for managing buildings HVAC. It was a new project and it uses Elixir. And it was with the help of Redwire. We've just finished delivering it as of the past month. And it leveraged our existing Nerves infrastructure, right? Our expertise, our knowledge. So I guess my point is we're now being able to take advantage of what we've learned over the last 5 years and iterate faster and reuse what we've already put in place, including our partners. That's the relay. What could have been better? I'm supposed to be over right now. I'm going to go fast. Could be better. Learning which consultants make effective partners. Right? That's a tough one. That would be a whole panel of how do you select consulting partners.
You can hang out on that slide for a while, Taun. That's okay.
How do you do OTA when there is very limited bandwidth? And if you're talking about 10 meg update and you don't have good bandwidth, that's just not going to happen. You got to figure out a way to make it manage it. So that could be better. We're still working on that. Fleet management, coming out of in the beginning with Nerves, it was okay, Nerves Hub, but it needs to be better, and I think it is going to be better with Nerves Cloud. I've been talking to Lars, and they have a lot of great ideas. CAD M1 was a bad choice for our LTE. We have an AAC connected device. CAD M1 was not the right choice. M stands for mobile. This wasn't mobile. This is not mobile. This is not mobile. These are plugged in. They have 120 volts. They have all the power they need. Go big. If you're picking a modem, don't worry about power. Worry about coverage. NB-IoT, totally unusable. Observability with low bandwidth. By observability, I mean Grafana, shelling, console, all that kind of stuff. It's much harder when you don't have any bandwidth. Not as hard as 300 baud dial-up, which I do remember, but it is hard. I actually, in my head, when I'm typing in a console, I internally keep track of how many characters back things are, because I was used to so much latency that if I needed to go back and change a letter, I knew exactly, before it actually finished showing the word, I knew how many backspaces I had to do, and then forward spaces, with it still not showing anything, that when it finally caught up, it was actually all correct. So the future, we've talked about how do we grow Elixir, how do we grow Nerves, how do we get more people, how do we hire when there's no one who can do it? Well, training, right? So at Fellows, we are actually training people for Nerves and Elixir. Christian is here. He is learning Nerves and Elixir. It is his first time at a Nerves or Elixir conference. He's working on his second PR. We're also training in China. So our FOP team, they see the writing on the wall. They've been working on firmware. There are firmware professionals. They know state machines. They know sensors. Well, now they're knowing how to do it with Nerves. And one of our Chinese employees have already submitted his command module sensor driver using Nerves, which is implementing the same interface that he'd actually been doing in embedded C firmware. So he's now doing Nerves. And they're going to be doing a lot more Nerves. They're going to be taking over our Nerves development, a lot of it. So yes, we're building it up. Submitting more PRs, training people. We're going to move more of the control into Nerves. I mentioned that we had that MCU that was pre-existing. Well, we're taking all that logic out of the MCU and sticking it in Nerves. Now that we've had experience with Nerves, we've been using it for years, we trust it, we find it's been a great development platform, we want more of it. Not less, more. We're going to try and make everything more modular. This is what I was talking about, where we have those sensors where they're just a separate gen server. They just run. Doesn't matter what happens if they crash. They go to a property table, very modular, being able to handle multiple sensors. We want better fleet management for low bandwidth. We're working on that. We want to go to Ethernet instead of LTE. And we want to make it physically more modular, where we can just plug in different modems, plug in different sensors, instead of having everything rigid and fixed. Okay, reached the end. I would like to thank Fellows for supporting this, for supporting me, supporting Nerves, the training, letting us come here, supporting us financially in coming here. Sponsoring, we did a sponsorship for Gig City, not for Nerves, but same thing, right? Sort of, almost. I would really like to do a shout out and thanks to partners that we've been working with over the years. JuiceWorks, they've been helping us with our UI, UX. They've been awesome. Nerves Cloud, we're using that for our relay. Again, really responsive, helpful. Peritio, that's the commercial Nerves hub. Redwire Labs. Redwire Labs have been great partners, so a huge shout out to them. Some links. Somehow this makes it out to the internet. And thank you all. Thank you all for being here.
We could do a couple questions if anyone's got. Cool. Ben, of course.
And I thought it was going to be too short.
That was perfect timing.
So, wonderful presentation. Near the beginning of it, you were talking about differences in the office space. You have sensors communicating like kind of across the whole space. There's a meeting room, right? People they don't want the air purifier being loud. And additionally, a thought in my head: office spaces are open 7 a.m. to 7 p.m. or so. So within your platform, is there any sense of that, and also physical control, right? People can on site do something. So within your platform, within this nerve system, do you have any sense of schedule management?
Yes.
Is it awful?
Is it awful?
Was it a nightmare to implement?
There were issues with it. It is simplistic. It's not probably at the level of schedule management that you're talking about. We've talked about there is quiet mode, and we can schedule the quiet mode. Of course, there are issues with time zones and timing. I think it's still a work in progress. Christian, do you have any opinions on that?
Very good. I will be talking later somewhat about this. So just kind of prepping everyone.
Right. Okay, thanks.
Yeah, scheduling and Ben don't get along. Any other questions? Cool.
John?
I mean, I've got a slew, but I'm gonna have to pick. How about this tablet here that we've been staring at that has
I have no idea what you've been seeing.
that has a
It
UI.
needs to be restarted.
Is this also Elixir under the hood running it?
Fortunately, no.
Oh, okay.
Right? And I say fortunately because obviously it wasn't working. And that is not a fault of nerves. This is
Yeah. That's what I was gonna guess.
It is. It was an attempt to get to market quickly. And well, this is version 1.
Okay, I want to redo. Then what I really want to know is about your pre-app startups.
Okay.
How are you starting some of those specific chunks that you were referencing before the rest of the application starts up?
The extra applications list, right? So they're listed as a dependency. So they're just like a library. And then in the extra applications, you can put the order of application startup in the extra applications. And so we have, okay, Bionic Eye should be first. And then LED status indicator should be second. And then Telet modem should be third. So that's our startup sequence. And once all that is done, then the application starts. Aha, there we go, John.
You mentioned, I saw the slide you had very few gen servers. Is that all encompassing of long-lived processes, state machines and agents and other things, or what? And also why? What's the problems you run into with gen servers?
So I started with Fellows a year ago. There was pre-existing application. That pre-existing application is what had very few gen servers. And that was comment, which I really skipped over because I didn't want to get too deep into it, was that there weren't enough gen servers. Yeah. So it's not me being anti-gen server. I'm not really anti or pro. It's like use it for what it's needed for, and don't use it if you don't need it. But there was definitely, for that original proof of concept app, a need for more gen servers, more isolation, more modularity. And that's what that comment referred to.
We can do one or two more. Cool. There you go.
Have you peeled back the onion of how fellows happen to pick Elixir and Nerves?
I think I know where that onion is, and I am not going down that path here. I need to explain myself a little bit at least, so I'm not going to leave that too hanging. Consultants. I think it was the right path, but so yeah, it's a difficult topic. I know the answer, and it's worked out. It's all good.
He said one or two more. So,
There's also someone back there.
shoot, should we go back there
no,
first?
Go ahead, finish.
Okay. So all of these devices that you have out, you said that there was a sensor sharing.
Yes.
I forgot the exact term, but are these devices distance aware from each other?
Not yet. That's future.
All right. So
future would be distance aware and space aware. Yes.
So to get the movement like you were describing, do you basically predefine the distance right now to say this is your physical location, and the backend knows how to perceive?
In terms of the hierarchy for the viewpoint dashboard and the spatial configuration, we have buildings, we have organizations, buildings, floors, and areas. And so the areas are where the sensor sharing comes in. So, for example, a conference room might be an area, or a whole open space might be an area. That's up to the customer for how they configure it and set it up.
Perfect.
Hi. So this is a slightly sort of generic question, maybe. So Nokia started being a gumboot manufacturer doing rubber and stuff like that, and ended up building cell phones. So you're like on a similar trajectory. Could you comment?
so.
So could you? Is that what the board thinks they want to be doing? I mean, can you comment about these types of things? You're a private company. You could
I have
not
no idea what
affecting the stock price.
I have no idea what the board thinks
when they grow up.
I have met John Fellows. He's the CEO. He's the fourth generation of the founding family. I think he's interested in being a profitable company, right? That is resistant to downturns, resistance to tariffs, having the ability to weather good times and bad. So I think he's doing a great job. Well, we have bankers boxes. We never left them. The manufacturing for bankers boxes is happening right under my desk in our office in Itasca. Every day we get to hear the pounding of heavy industrial machines right below our floor, putting out bankers boxes, and it's awesome.
So early on, you said the customer service kind of infrastructure wasn't really in place. So you really had to make sure that things weren't going offline, that things didn't have to be replaced. And specifically kind of talking about the microcontroller and, the peripheral devices. Is there anything that you can think of or that you can, share with us that maybe primarily helped you achieve that goal of really reducing or eliminating connectivity issues?
OTP. If it crashes, reboot it, right? I mean, the supervisor, that's been huge. There's a modem issue with the driver, well, it's going to restart. There is such a thing, and that would be a great topic for another talk, of letting it crash too much and having too much of a blast radius for letting it crash. you do want more control, but OTP, absolutely.
We got time for one more.
Supervisors are awesome.
I was wondering, like, I don't know much about nerves, but there is idea in OTP called hot code reloading. Are you using some ways for OTA updates? I'm just curious.
We are not using hot code reloading for anything except troubleshooting, debugging, analysis, right? So we will shell in and copy and paste code and change the behavior on the fly, and then see, oh, did that work? Or maybe even put in diagnostic code on the fly and run that. So that's been an awesome feature of Elixir as well, or Lang.
Cool. Thank you, Taun.
Thank you, everybody.